for Lesson 29, we're going to extend our work with equations to multi-step problems with all operations. So we'll start with example 1, in which the school librarian, Mr. Marker, knows the library has 1,400 books, but wants to reorganize how the books are displayed on the shelves. He needs to know how many fiction, nonfiction, and resource books are in the library, and he knows that the library has 4 times as many fiction books as resource books, and half as many nonfiction books as fiction books. If these are the only types of books in the library, how many of each type of book are in the library? So we're going to need to draw a tape diagram to represent the total number of books in the library, and then 2 more tape diagrams, one to represent the number of fiction and one to represent the number of resource books in the library. So in starting off, we have a large tape diagram representing the 1,400 books that are in the library. Then we have 2 more tape diagrams. One is the resource books, and we know that there are 4 times as many fiction books as resource books. So I made a small section of resource books and then 4 times that for the fiction books. We also know half as many nonfiction books as fiction books, but our resource books doesn't have anything else but the fact that there are 4 times as many fiction books. So our variable should be the R that is representing the number of resource books. And then, since R represents the number of resource books, we can write the expression for fiction books, which would be 4 times R. Interestingly enough, when we go back into our problem, it says the library has 4 times as many fiction books as resource books. We have that. And half as many nonfiction books as fiction books. So if 4R equals the number of fiction books, then 1/2 times 4R would equal the number of nonfiction books. And if we drew the tape diagram for that, we would take our 4R and we would cut it in half, which would give us 2R. So we'll put in parentheses 2R is the number of nonfiction books. Now I've skipped down to writing an equation that represents the tape diagram because we've talked through all of those parts. But ultimately what we have then is R, the number of resource books, plus 4R, which is the number of fiction books, plus 2R, which is the number of nonfiction books, and altogether they equal 1,400 books. From here then we can determine the value of R. And the best way to do that is to first of all look at how many R's we have in this problem. We have 1 R plus 4 more, that's 5, plus 2 more, which is 7 R's. So 7 times R is equal to 1,400. And then, if we divide by 7 on both sides of the equal sign, which is how we would solve this algebraically, we find that R, or the number of resource books, is equal to 200. And then we can find the number of fiction and nonfiction books by using R in our original expressions. So we have 200 resource books. And then 4 times R, or 4 times 200, would be the fiction books. And then 2 times R, or 2 times 200, which is 400, would be our nonfiction books. If we add the 3 numbers together, we should get 1,400, and we do. Next, we have some exercises to help practice the concept together. So our first one, Indian Ridge Middle School wanted to add a new school sport, so they surveyed the students to determine which sport is most popular. Students were able to choose between soccer, football, lacrosse, or swimming. The same number of students chose lacrosse and swimming. The number of students who chose soccer was double the number of students who chose lacrosse, and the number of students who chose football was triple the number of students who chose swimming. If 434 students completed the survey, how many students chose each sport? I think it's extremely important for us to adopt a method and then use that method on a regular basis so we get good at it. And I would suggest to you in this in this instance, we need to put a tape diagram in for each one, which will help us then to write the algebraic expression that matches it. So first I've drawn the tape diagrams according to the information given in the problem. They told us that the same number of students chose lacrosse and swimming, so I made a tape diagram each for lacrosse and swimming, and they were the same size. I labeled them as we should with all tape diagrams. If you start drawing and you don't label anything, it's not going to be any more helpful than just reading the problem over and over again. Next, they told us that the number of students who chose soccer was double the number of students who chose lacrosse. And so I took the soccer tape diagram and I made it roughly twice as big as the lacrosse, which remember is the same size as the swimming. And I may not recognize that if I don't draw the tape diagram, and I labeled that tape diagram soccer. Then they told us that the number of students who chose football was triple the number of students who chose swimming. And looking back at the tape diagram, I know instantly that swimming was the same size as lacrosse. So I went down, I drew my football tape diagram, which was roughly 3 times as big as the lacrosse or the swimming ones, and I labeled it football. And you'll notice that I put dividing lines in both soccer and football so that I could show twice as big and 3 times as big as those original tape diagrams. At this point, now I am ready to start choosing some variables and writing some algebraic expressions that match. So when I look at it, I believe that what we can do is label lacrosse and swimming with the same variable. And I guess for this example, I will use an S. So lacrosse, we'll label S. Swimming, we'll label S. I chose not to use the L because it looks like a 1. Soccer has 2 pieces that are the same size, which is S. And football has 3 pieces, which is the same size as well, also S. Now at this point in the problem, it should start looking rather easy to you. Because we know now at this point that 434 students completed the survey. That means that all of these pieces added up must be 434. And now we need to determine how many students chose each sport. So we're going to need to write an equation. And I have 1, 2, 3, 4, 5, 6, 7 S's. So 7 times S is equal to 434. And I can solve that equation by dividing by 7 on both sides of the equation. 7s divided by 7 is s. That was the whole point. And 434 divided by 7 is 62. So that means that each piece in the tape diagram is 62. Now they asked us how many students chose each sport. So now we'll have to take our information and put it into an answer which lists all of the students' choices. Lacrosse was 62 students, swimming was 62 students. And so when I put all the pieces together, both lacrosse and swimming have 62 students, soccer has 124 students, football has 186 students. And we should put that back into our equation, which was 7s equals 434. And when we put that back in, 7 times 62 does indeed equal 434. Question 2. At Prairie Elementary School, students are asked to pick their lunch ahead of time so the kitchen staff will know what to prepare. On Monday, 6 times as many students chose hamburgers as chose salads. The number of students who chose lasagna was 1/3 the number of students who chose hamburgers. And if 225 students ordered lunch, how many students chose each option if hamburger, salad, and lasagna were the only 3 options? So again, we're going to make the tape diagrams for all 3 choices. So then what we have are salads, hamburgers, lasagna, and the salad seems to be the base size. So our variable we'll use as s. That means, of course, that hamburgers, they told us, are 6 times as many students chose hamburgers as chose salad. So my pieces aren't exactly to scale, but you're going to have the same thing happen to you. And I'll fill in the s for each one of these pieces. And then they told us that lasagna was 1/3 the number of students who chose hamburgers. And hamburgers had 6 pieces. So 1/3 of 6 pieces is actually 2 pieces. So I'm going to go back to lasagna and I'm going to label it 2s. I could cut it into 2 pieces, but just as a shortcut here, we're going to label it 2s. Now at this point, we have all of our tape diagram in place and we can now create our equation. We might write something like s Okay, so we have our work. I double checked to make sure that our original equation, 9 times s, or 9 times 25 equals 225. And then took each part. Salads was 25, hamburgers were 6 times s, which was 150, and lasagna was 2 times s, which was 50. And a second time I double checked to make sure that 150 plus 50 plus 25 equals 225, which it does. The art teacher, Mr. Gonzalez, is preparing for a project. In order for the students to have the correct supplies, Mr. Gonzalez needs 10 times more markers than pieces of construction paper. He needs the same number of bottles of glue as pieces of construction paper, and the number of scissors required for the project is half the number of pieces of construction paper. So if he has collected 400 items for the project, how many of each supply did he collect? We have 4 different supplies, so we'll need 4 different tape diagrams, so we'll draw those first. Now when we look at our tape diagrams, we know that he needs the same number of bottles of glue as pieces of construction paper. So we're making the paper and the glue the same size. And we're going to call this, well, let's call this P. Then we know that he needs 10 times more markers than pieces of construction paper. So we have markers, and there are 10 pieces here. Each one is P. And honestly, since we know they're all the same, we could write at the end of this line 10P, 10 times P. And then we know the number of scissors is half the number of construction paper. So this, and I made it into 1/2, we could label at the end of that 1/2 times P. Altogether, we know he has 400 items for the project. So now we're ready to write the equation, which would be P plus 1/2 P plus 10P. And that is all equal to 400. We'll need to combine those like terms. We have 1P plus another P, which is 2, plus 1/2, which is 2 and 1/2, plus 10, which is 12, and 1/2 times P is equal to 400. Now in this, we'll need to do a little work with fractions. So what we're going to do is divide by 12 and 1/2. 12 and 1/2 P, and we're going to divide by 12 and 1/2. Remember, on both sides. And I would believe that some of you will really just want to change 12 and 1/2 into 12.5. And you're certainly welcome to do that. And we find that 400 divided by 12 and 1/2 is 32. So when we go back, we would write paper, "32 sheets of paper, 32 bottles of glue, 16 pairs of scissors, and 320 markers." And we would also then add all of them up to make sure that they equal 400. 64, 32 plus 32 is 64, plus 16 is 80, and 320 plus 80 is 400. In our final exercise, the math teacher, Ms. Zentz, is buying appropriate math tools to use throughout the year. So she's planning on buying twice as many rulers as protractors, and the number of calculators she is planning on buying is 1/4 the number of protractors. If Ms. Zentz buys 65 items, how many protractors does Ms. Zentz buy? Now some of you may have been thrown off by the 1/2 that I used in the last problem. So in our tape diagrams this time, let's try to make them so that the smallest of our pieces is 1 and the rest of them is more than that. Now before we get too far, I want to show you that the number of calculators is 1/4 the number of protractors, and so the smallest number we're looking at are calculators. I'm going to put that in first. And remember, the number of calculators she's planning on buying is 1/4 the number of protractors. So I made my second tape diagram for protractors 4 times as large as the calculators. And I'm labeling these two first because I don't want to confuse it later on. Calculators, protractors. Now, she's also planning on buying twice as many rulers as protractors. So you can see that our protractors is 4 times the number of calculators. So I'm going to need a tape diagram for rulers that is even larger than that. And so what we have are calculators, 4 times as many protractors, and rulers, which is twice as many as protractors. So there were 4 pieces for the protractors, we'll have 8 pieces for the rulers. Now under this circumstance then, I'm going to use C for our variable, which is the number of calculators. And then protractors would be represented by 4 times C, and rulers would be 8 times C. Our equation would then be C plus 4C plus 8C is equal to 65. And we'll combine all of the C's together. 1C plus 4C is 5 C's, plus 8 more is 13 C's, which is equal to 65. And then to solve that, we'll divide by 13 on both sides. And we find then that C is equal to 5. So then we have 5 calculators, 4 times 5 or 20 protractors, and 8 times 5 or 40 rulers. We'll add them back up to make sure. 40 plus 20 is 60, plus 5 more is 65, and that was the number of items that she purchased.